going to be talking about, last class we talked about how to change from exponential into logarithmic form and vice versa, right? So we said that the inverse of an exponential was what? What's the inverse of an exponential? Say it again. A logarithm. The inverse of an exponential is a logarithm. What's the inverse of a logarithm? An exponential. Okay, so that's what we did last class. So this class, we're going to start to talk about how we work with these logarithms. They have some special properties that go along with them. Okay, so turn the page for me, please. All right, so we have some rules that follow along with logarithms. First rule, if I have log base b of m times n, when we have this piece here that's in the parentheses, there's special rules that go along with it. So what happens when we have this is we get log, everybody has to put this down, base b of m plus log base b of n. So what happened here? What did I do? What did I go from? How are m and n connected here? Multiplication. Where did I go to? Addition. Okay, so these properties of logarithms, they kind of expand or they smush. Okay, this is an expansion. We're going from multiplication to addition and we're expanding it out. Okay, so they'll literally ask you, expand the logarithm. This would be how we would expand this logarithm. All right, so multiplication went to addition. What do you think division is going to go to? Subtraction. Okay, good. So we've got log base b of, what do you think? M. What am I going to have after that? Good. Log base b of n. Yes, because they're starting capital, so you want to keep them capital. All right, so multiplication went to what? Addition. Division went to subtraction. And they kind of go along together, right? All right, so the last piece is, notice we have that exponent. When we're dealing with logarithms, what we do with exponents is we bring them out front, okay? And I still have my caps on, sorry. So we bring them out front. So this is going to be x log base b of m. So the exponents pop out front. Those are the three rules, okay, to expand. We're also going to use those same rules to work backwards as well. So multiplication is going to go back to, I'm sorry, I said, yeah, multiplication goes to addition, so addition would go back to multiplication if I wanted to smoosh it back together, right? If I had subtraction, what would I smoosh it back together? Division. So they work as inverses of one another. Does that make sense to everybody? All right, so let's give it a shot. Next page. Okay, smoosh the logarithm. When I say smoosh, I mean condense, okay? Condense is just the bigger word for it. All right, so subtraction, what am I going to smoosh it to? Division. So the way I'm going to write this is we're going to go from 2 logarithms to 1. So put your log in. Is the base going to change? Nope. And what am I going to put in those parentheses? 8 over 4. Good. And that is the same thing as, do I need to leave it 8 over 4? You could put it as 2, or you could leave it as 8 over 4. For this purpose, what I wanted you to see is how to smoosh it back together. But you can go ahead and give that last step. Just make it a 2. Good. Condense. They would not use smoosh. That's just my own special word. How to put it in what way? No. Okay. Are we all right with that? How to condense it, how to smoosh it? All right, next page. Okay, so this one's a little bit harder because now we've got an extra step, right? We're going to expand this one. So what do we have in here? We've got an exponent and we have multiplication. Which one do you think you should hit on first? Okay, if you hit on the exponent first, you have to be very careful because what is that exponent going to? Is it going to the x, the y, or both? Just the x. My suggestion would be to change the multiplication first so that you can get to that exponent. Okay? It's kind of like working opposite order of operations. All right? So let's stretch it out by changing that multiplication first. How are we going to do it? Hold on just a second. All right, does anybody want to give me my first step? Any takers? Yes, Mike. Oop. Okay. Good. Nice job. Okay. Who wants to finish it for me? Edith? Okay, which one's your exponent, the x or the 3? So what are you going to move? 3. Mm-hmm. Good. 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 And then you keep what you had because that doesn't change, right? Okay. How'd we do? That's expanding a logarithm. Okay? So we're just using those 3 rules that we had at the beginning to expand. Demetrius, do you have the cable? Can you please give her lesson 23, please? Thank you. Okay. So let's go to the next page. Take a peek. Now, can I expand this? No. So what am I going to do? Smoosh it or condense it, simplify it. All right, so go ahead and smoosh this one. All right, so Kirsten, want to put it together for me, please? Which reduces to 5. Okay, now what if I wanted the solution to this? How would I go about finding it? Type it in. Okay, so I'd like you to find what this is equivalent to, what it's equal to. So you're going to take literally 2 seconds, add a calculator page, pop it in, find the solution. What do we get? That's good. Not 11. 1.464. And that you got just by popping it into your calculator, correct? Okay, good. Easy? Not too bad? All right, next page. Now, notice we have a number sitting out front of a log, right? So when I smoosh this, where's it going to go? Okay, so I want you to go ahead and give this one a shot. Okay, so addition goes to multiplication, and my number up front is going to become a exponent. That exponent, is it going to go to the x, to the y, to both? Just to the x. Okay, so who wants to give this a shot? Brianna? Uh-huh. Perfect. Very nice job. How many people got this right? Okay, for those of you that didn't get it right, where did you go wrong? Where did we go wrong if you got it wrong? Was it the exponent? Is there anybody in here that did not get it right? So when I said, raise your hand if you got it right, those of you who didn't raise your hand didn't hear me? Yeah. All right. So I want you to write this as a single logarithm. Now, if there is no base written, what is the base? 10. And we call that what? you remember the term for it? Nope. Natural logarithm or common logarithm? Okay. All right, so go ahead, make it one. You're going to smoosh it all back together. So you've got an exponent, you've got addition, you've got subtraction, put it all back together. Okay, so you guys ready? You need to stop talking now. All right, so that 3 is going to become what? The exponent. What's 2 cubed? 8. Okay, so we've got log 8 plus log 4 minus log 16. Addition becomes multiplication. So now I've got log of 8 times 4. So let's pop that in there. Log of 8. Oops. Right? And we still have on the end minus log of 16. You okay with that? Notice I didn't put the 10s. Do I need to put them? No, it's a common logarithm. Oh, yeah, sure. I don't care. No, we're not done. 8 times 4? 32. Subtraction becomes division. So we get log, oops, of 32 divided by 16. Okay. Should I leave it like that? What's 32 divided by 16? There you go. That's your answer. Everybody get that right? Yep. All right, I want you to write this logarithm as a single logarithm. So go ahead and give this one a shot. Take a minute. Okay, so that 3 out front, where's it going to go? As an exponent. So you should have at least gotten this far. But then what becomes the problem? The bases aren't the same. So can we do anything with this? No. What we'd have to use is what's called a change of base formula, which we have not done yet. We'll maybe get there. We'll see. So right now, for what it is, we're going to leave it. Okay, we'll come back to that another time. All right, so go to the next page. There are 1, 2, 3, 4, 5 logarithms that I would like you to expand. You can do them in your calculator, you can do them on paper, whichever you prefer, but that is what you are doing, okay? Your homework tonight, I have this worksheet front and back. I'd like you to do 5 on the front, 5 on the back, and we're going to do the rest for practice, so we will get this entire thing done. The worksheet, let's see here. Okay. All right, so work on these 5.